In this video, we're going to be covering mechanical advantage. So what is mechanical advantage? It's the measure of the force application via a tool or machine. So essentially, it's how much you can increase your force by using something else. So let's say that we have different formulas that we want to be able to calculate and use. So actual mechanical advantage is when you are considering things like friction, and it's the ratio of your output force, which is the force that the machine is going to exert on the load, is equal to the force machine exert on load over the force that you input into the machine. So that is equal to the abbreviation AMA, your actual mechanical advantage. And I'm gonna say this accounts for when you have friction. So after this, we can also talk about ideal mechanical advantage. Ideal mechanical advantage is going to be when you have the theory of a ideal perfect machine without friction. So this is determined by the dimensions and geometry of the machine. So for example, that's when you have a theory of something, of how something would work if it was absolutely perfect, like a perfect seesaw. So the formula is going to be when you have your D input divided by your D output. In the real world, AMA is always going to be less than IMA because energy is lost to friction. And also in the ideal world, you would always have a greater amount of mechanical advantage. Now, what about efficiency? What is efficiency? Efficiency is going to be a measure of how well a machine converts input work, aka inputs work or energy into useful output work. But because of energy losses, usually friction, your efficiency is always going to be less than 100%, which is also going to be equal to 1.0. So your efficiency formula is represented by this symbol here. Looks like an N. And this is equal to the work you output over the work you input. And to convert this into a percentage, you multiply that by 100%. Work output is going to be the useful work accomplished. And work input is just the work into machine. Now, we can relate this to mechanical advantage. So if you know AMA and you also know IMA, you can calculate efficiency. Write that down here, actually. So you can also write this as your actual mechanical advantage over your ideal mechanical advantage times 100%. So usually, if you are provided distances, like input distance versus output distance, you're going to use that to find your IMA. But if you are provided forces, you want to use those to find AMA. And if you have both, use those to find the efficiency. Now, let's do some practice MCQ with this topic. So let's say we have a machine that lifts 200 Newton load by applying a 50 Newton force over an 8.0 meter distance, raising the load by 2.0 meters. What is the efficiency of the machine? So here we're going to draw out our load. This is our load. And it's going to be a 50 Newton force upward. The distance of this 50 Newton force that is going to make the object move by is going to be 8.0 meters. And this load again is 200 newtons. So we want to find what the efficiency is. So before, it used to be down here. That's 2.0 meters. So this is your final state. It used to be at the bottom, but then it was moved up 2.0. So we have to find what the input work is. That's going to be your force that's in and your distance in. So you have 50 times 8.0, which is equal to 400 joules. Now for the work out, that's going to be equal to the F out times the D out, and that's going to equal to 200 times 2.0, which is equal to 400 joules. To find the efficiency, you're going to take the fraction of this, 400 over 400, that's equal to 1.00, aka 100%. So the efficiency is 100%. A pulley system has an ideal mechanical advantage of 4. If the efficiency is 80%, what is the actual mechanical advantage? AMA. So we're going to use the relationship that efficiency is equal to your AMA over your IMA. And your AMA, if you rearrange this algebraically, is equal to your efficiency times your IMA. So that would just be 0.80 times 4, which is equal to 3.2. So your answer is B. A machine has an input work of 500 joules and an output work of 350 joules. What is the efficiency? So our efficiency is going to be measured in work out over your work in. So this is going to be 350 over 500, and that's equal to 0.70, which is going to be equal to 70%, which is C. A lever system has an input force of 40 newtons applied over a distance of 5.0 meters, lifting a load 1.0 meters. So you're going to look at your input, which is 40 times 0.50. No, that's times 5, which is going to be 200 joules. So your output work is equal to your input work when you have an ideal system. So our work output would therefore be equal to the input that we just calculated, 200 joules. So if we want to solve for the work out, we're going to say that's equal to F out, D out. We can actually substitute that 200 in there. Now we can solve for F out. So that's going to be times 1.0. So F out is just equal to 200 newtons. So your answer is C. A ramp raises a 600 Newton load to a height of 3 meters using an applied force of 200 newtons over a distance of 10 meters. What is the efficiency? So your efficiency is equal to AMA over IMA. So AMA is equal to your efficiency times your IMA, and that's equal to 0.75 times 3 equals to 2.25. And now you need to solve for your output force. So AMA is equal to F out over your F in. You're just combining different equations, and you're just different equations and formulas, and you're just trying to solve for what you need. Is equal to your F out over your 120. So that's equal to, for your F out, you can rearrange that algebraically. Multiply both sides by 120 and you get 225 times 120 is equal to 270 newtons, which is going to be equal to your option B. So a machine has an efficiency of 75% and requires an input force of 120 newtons to lift a load. If the ideal mechanical advantage is 3, what is the load lifted? So if we use our efficiency relationship, that's efficiency is equal to your AMA over your IMA like we saw earlier. So again, you can rearrange this. AMA is equal to your efficiency times your IMA. And here that's going to be 0.75 times 3, which is equal to 2.25. And your F output is going to be equal to a rearranging a form of AMA. So we have AMA is equal to F out over your force that's you put in. So that's going to be 2.25 is equal to F out divided by 120. So F out, if you multiply both sides by 120, you get, this is equal to 2.25 times 120. And that's equal to 270 newtons, which is going to be option B. A system has a mechanical advantage of 5 and an efficiency of 50%. What is the ideal mechanical advantage here? So your efficiency is going to be equal to AMA over your IMA. And your IMA is equal to your AMA over your efficiency. So that is equal to 5 over 0.50 here. So 5 over 0.50, that's just going to be 10. So your answer is going to be C. Now, a machine does 800 joules of input work and loses 200 joules of friction. What is the output work? So your work output is equal to your work in minus your work that you lost. So that's going to be equal to 800 minus 200, which is equal to 600 joules. And that is option B. A machine has an ideal mechanical advantage of 6, but an actual mechanical advantage of 4. What percentage of that work is lost? So you have to first measure what your efficiency is, and that's going to be AMA over your IMA, and that is equal to 4 over 6. So that means your answer for this is 0.667 as a fraction. So to find your loss, you're going to set that equal to 1 minus your 0.667, and that's equal to 0.333 approximately. Or this is our exact value, because we just use our exact values for our fraction for our decimals. So this is going to be 33%, which is going to be option C. A machine doubles the output force but requires 4 times the input distance compared to the output distance. What is the efficiency? So your efficiency is going to be measured in your work out over your work in. Your work out is equal to your F out over your F out times your D out. So that's going to be equal to that. So now for work in, that's going to be F in times D in. And we can substitute in our expressions here. So dn here, dn is going to be equal to 2 times, or is equal to 4d out. And our F out is equal to 2F in. So now we can create a relationship with all of this. We can plug these into efficiency. So we're going to take work out and plug this in here, and you're going to take work in, you're going to plug this in here. So you're going to have your efficiency is equal to your 2 times your F in times D out divided by F in times 4 times D out. So if you cancel everything, you can cancel your in and you can also cancel your out. You can see that your relationship is 2 over 4, which is equal to 1/2. And 1/2 is equal to 50%. So your answer is going to be B.